So welcome to our September New Jersey Coastal Resilience Collaborative Technical Assistance Coffee Chat. My name is Amanda Archer. I'm the Coastal Training Program Coordinator at the Jack Cousteau Reserve, and I am a partner with the New Jersey CRC and Technical Assistance Workgroup Lead. For those who are here for the first time, the NJCRC is a network of coastal resilience professionals, and the purpose of this coffee chat program is to better facilitate connections between local communities and stakeholders who have technical assistance needs with New Jersey CRC members who can assist with those needs. I just want to remind everyone that the views expressed during this technical assistance coffee chat are the presenter's own and do not reflect the official policies or positions of the New Jersey Coastal Resilience Collaborative or any of its organizational partners. So the focus of today's coffee chat is on the newly passed Inland Flood Protection Rule. The rule incorporates the use of updated climate precipitation data for new development or redevelopment in areas that are at risk of inland or riverine flooding in New Jersey. The rule would ensure that areas at most significant risk are better defined and that new and reconstructed assets in these areas are designed and constructed using the best available climate-informed precipitation data. Municipalities will also need to utilize the precipitation data generated by these studies when considering stormwater designs for residential development. And municipalities will need to update their local ordinances before these new requirements apply to non-residential developments at the municipal level. With that, I would like to introduce our first guest speaker today, Dr. James Shope. James Shope is an Assistant Extension Specialist in Climate Services with the Rutgers, New Jersey Agricultural Experiment Station and the Department of Environmental Sciences. His research focuses on applicable climate resiliency for communities, agriculture, and public health in New Jersey. And so, James, we can have you share your screen and take it away.
Sounds good. Going to do that. All right. And do you see the presentation?
I do.
Awesome. I'm going to get like a little laser pointer here. All right. So as Amanda said, I'm James Shope with the Experiment Station out of Rutgers. And today I've been asked to speak about the background for the Inland Flooding Rule, basically how climate change is affecting rainfall throughout New Jersey. So it's going to sound a little weird, but to understand how rainfall changes, we need to understand how temperature is changing globally. So just a really brief climate change overview. As we increase greenhouse gas concentrations in the atmosphere, that ends up warming up the earth. So we burn fossil fuels for energy. It produces carbon dioxide. We also release methane and other greenhouse gases. And that warming has led to about a 2 degrees Fahrenheit increase in temperatures in the past century globally. And we see that in this graphic here, where we have the black line is the annual mean temperature for the globe measured over the earth, over the land and the ocean. The red line is just a mean through that, so we can see the trend more easily. And it's relative to the average of the last century. So that's why there's some plus and minuses here. But the big thing to understand is just this general trend. We see that temperatures have been increasing, and since about 1970, they've been increasing at a faster rate. And that's driven by anthropogenic or human-caused climate change. And we expect to see that continue into the future. So pictured here is from the Intergovernmental Panel on Climate Change's most recent technical summary. Showing change in historical temperatures relative to this kind of pre-industrial period of 1850 to 1900. Now it's in degrees Celsius. It's in an international document. That's just kind of how that goes. But similarly, we had this black line showing historical temperature observations. They've been increasing, and we expect to see that continue into the future. So we have a suite of what we call warming scenarios based on technology, based on our policy regarding emissions, based on just human action. So this blue scenario has us with a lower amount of warming by the end of the century. The red have us at a much higher level of warming globally. And where we're tracking currently is most closely with this gold scenario here. So that puts us at about 2.7 degrees of global warming relative to this pre-industrial period by the end of the century. So what's the outcome of this warming? Well, it causes a lot of variability and amplification of our severe weather and our climate systems. So maybe we see an increase in extreme storms and coastal flooding hazards. We see changes in precipitation patterns and heavier rainfall in certain areas. So we're going to be talking about that, or drier conditions in others. Or it can create conditions that are conducive for other hazards like wildfires. So it's important to understand how these global temperature and regional temperature effects actively impact the climate system. Now, in New Jersey, we see a very similar change in temperature in terms of the pattern. So here in orange are the actual annual average temperature measurements in New Jersey from 1895. In this case, it's to 2021. The green line is just, again, a mean through that. And then we have the mean of the last century as this black line for reference. And what you'll see is a very similar pattern whereby temperatures have been increasing, but since about 1970, they've been increasing at a much faster rate. And I'm harping on that because we see that paired with more intense rainfall throughout the state. And then for reference, in New Jersey, the actual swing in temperature has been closer to about 4 degrees Fahrenheit about since the start of the last century, so about twice the global average. And just like global temperatures, we expect to see this increase into the future based on our emissions. So this is now looking at temperature change in orange against the same line that we saw before, relative to the average between 1900 and 1960. That's what this black line is. And then we have our projections for temperature change with lower and higher greenhouse gas emissions. With lower emissions, we expect our temperatures to be about 2 to 8 degrees warmer than this baseline. And then with higher emissions, it's about 8 to 14 degrees. So again, in New Jersey, we're going to see a lot of warming moving forward. So that warming is very important because of this relationship here called the Clausius-Clapeyron relationship. And the simple thing is, for every degree that the atmosphere increases in temperature, it can hold about 7% more water. So that's really dependent on water available for evaporation. Here in New Jersey, that relationship's pretty strong. We're in a humid location and plenty of water. If you're in Arizona, the water can hold about 7% more water, but there's no water to actually populate that. But as it warms, there becomes more water available for rainfall. Now, that doesn't necessarily translate directly into rainfall, but it means that there's more availability. So what we see with an increase in temperature globally and regionally is we see an intensification or an amplification of the hydrologic cycle. We have more heat that drives more evaporation, meaning that we can have more water available for more intense rainfall. And of course, that ends up leading into more flooding down the line. Now, in some locations, this creates drier conditions, but we're focused on rainfall in this case. So specifically in New Jersey, we're going to have more water available for evaporation, driving this intensification. And as I mentioned, it creates this availability of water for heavier rainfall, but it doesn't always mean that we're going to get it. Rainfall is very variable. So it means that there's potential for any individual rainfall event to produce more rain. And we see that reflected in global studies as well. So the Clausius-Clapeyron relationship is a very generalized chemistry relationship. And it's broadly true, but it doesn't actually translate exactly into what we see with extreme rainfall. So this is showing the percent change in heavy rainfall for that red scenario we saw earlier, for higher degree of warming by the end of the century for globally. And if we were to focus in on Eastern North America here, it doesn't show a 7% increase. It shows about an 8 to 10% increase in rainfall per degree of warming for extreme rainfall events, so a big storm. So what this underscores is, yeah, we have more water available, but it also looks like moving forward, our rainfall is going to become more intense. So that's just kind of the projection overall. Now I want to dive into New Jersey specifics. So this here is pictured the average total precipitation throughout the state in green from 1900 to 2021. The black lines are means each decade, just to help us see what's going on. And the precipitation here is in inches. So a few things you'll note. As I mentioned before, rainfall is inherently extremely variable. We have a lot of swings from fairly wet to fairly dry years, but that variation is becoming more pronounced in recent decades. From about 1970, as I mentioned, that's when our warming started to become stronger. We see a lot more variability in our rainfall. We're basically oscillating more dramatically from very wet years to much drier years. If we look at the actual average, though, in rainfall, in these decadal means, we don't see much of an actual change in the total amount of precipitation over the long haul, about a 7% increase. But that being said, the top 5 wettest years have all occurred in New Jersey since 1975. So we are getting more rainfall, just not a ton if we look at it over this long term. But we're seeing a more noticeable effect is with extreme rainfall. So extreme rainfall in New Jersey is becoming more frequent and larger. So pictured here on the left is data from the National Oceanographic and Atmospheric Administration, showing the number of days with rainfall of 2 inches or more throughout New Jersey. The black dots actually represent that number each year. It's an average, so that's why you have some non-whole numbers here. And then the green bars represent 5-year averages. And then the black line is just the average through that. And it's a little hard to parse, but there's a few things you'll notice. These black dots, we have some very high peaks, especially in more recent decades. And in terms of the average, if you kind of ignore this last little bar here, that's from 2014 to, 2014 to 2019. It's not as high, but the general trend is towards more extreme rainfall. And if you were to add the bar of the most recent 5 years onto this, you would see it be very high as well. And of course, we have the consequences of that, primarily flooding. Pictured here is flooding in New Brunswick after Hurricane Irene in 2011. So we expect to see more intense rainfall followed by flooding, flash flooding, riverine flooding, and the like throughout the state. And a really good example of what this may look like in the future as we see more extreme rainfall is what we saw with post-tropical storm Ida in 2021. So Ida was a hurricane in the Atlantic. It made landfall in Louisiana, and then the storm system itself persisted over land, so being downgraded from a hurricane to a post-tropical storm, hence the nomenclature, and arriving in New Jersey from the southwest on September 1st. It brought with it torrential rain. It caused 30 deaths throughout the state, primarily due to flash flooding, representing the second greatest loss of life in the state from a natural event, only exceeded by Hurricane Sandy. And throughout the Northeast as a whole, the damages were somewhere in the ballpark of $16 to $24 billion. Now, what was strange about Ida is the intensity of its rainfall given the time. So we had the heaviest rainfall in Hillsborough and Flemington within the state, and it exceeded 9 inches of rainfall in about like 6 hours. And if we were to look at the weather station here in Newark, it was over the 1,000-year event. We think about storms, we talk about the 100-year storm, the 500-year storm. Well, this was the 1,000-year storm in terms of rainfall in Newark. And if we look at this graphic here, this is showing for 6-hour intensity how frequently we'd expect to see that rainfall amount, whether it's the 10-year storm, the 100-year storm, et cetera. And large swaths of the state exceeded, especially in this kind of more north central part of New Jersey, the 1,000-year event. And again, the flooding was intense. Flash flooding was about 10 to 20 times the typical thresholds that meteorologists, people on the Weather Channel use to issue flood warnings. And Ida may be more of an indication of what we're going to see in the future. So not every storm is going to be an Ida by any means. This is a very big storm in terms of rainfall, but we're going to start seeing more storms trend towards Ida in rainfall intensity and amount. So with that in mind, knowing the kind of climate change and stuff, we also have a few data sets that we can look at. So historically, people have referred to the NOAA Atlas 14 data set. And that provides precipitation frequency estimates for the whole of the US. It's a very good tool because it has very high resolution. But there's a problem with it. As I've been talking about the entire time so far, our rainfall patterns are changing. And this Atlas 14 data set that's, again, typically used by planners, engineers, and the like, is based mainly on historical rainfall. And in New Jersey, it only includes data through the year 2000. So there's 23 years worth of data that are not being accounted for, 23 years of climate change that are not being accounted for in this. And so we call this phenomenon where the assumption is that the climate system doesn't change, stationarity. And that's kind of baked into this Atlas 14 data set. So what we're thinking about is Atlas 14 is a useful tool, but since it doesn't account for climate change, it's not the most useful tool moving forward when we're needing to think about what kind of planning needs to happen for our future rainfall here in New Jersey. So the state DEP recognized this and commissioned 2 different studies on rainfall throughout the state. The first is titled here, Changes in Hourly and Daily Extreme Rainfall Amounts in New Jersey since the publication of the NOAA Atlas 14 dataset. And it added data, I believe, through 2020, 2021. Vince will probably correct me on that. But what was great about it is adding that data showed that there was an increase in intense daily rainfall since 2000. Basically, we see the climate change effect in our rainfall. And it updates that data set for us. And in many weather stations throughout the state, extreme rainfall amounts were about 2.5% higher than in the year 2000. Now that doesn't sound like much, but the Atlas 14 data is based on some 50 years worth of data. And by adding roughly 20 years to that, we're shifting that needle in terms of our expected amount of extreme rainfall a bit. We're showing a disproportionate effect. And then what's driving this is that new rainfall events they found were exceeding the previous maximum. So we're seeing rainfall that we have not seen to the same degree ever before in the past. And we're seeing a higher frequency of more extreme events that are driving this observed change. So generally a lot bigger. And if they're not the most superlative events, we're still seeing very big rainfall events with this data set in this study. Now, the second study, and this is going to be very important for our next talk, is looking at how rainfall may change in the future in New Jersey. So this study was projected changes in extreme rainfall in New Jersey based on an ensemble of downscale climate model projections. That's a mouthful. Basically, what they did was they used climate models to project how extreme rainfall may change. And they used 46 different climate models to do this. I'm not going to get into all the methodology, but from those climate models, they did a calculation method similar to Atlas 14. So you're comparing apples to apples. And what they found is an increase in extreme rainfall across the state. So by the end of the century, best guess estimates for a higher emission scenario showed a 10 to 30% increase in extreme rainfall. So an individual rainfall event may have a 10 to 30% more greater amount of rainfall that it produces. And for moderate emissions, so kind of more closely what we're tracking, we're looking at a 5 to 15% increase. And there's a lot of variability in this. If you look at the study, it even states there's a lot of variability, but these represent some of our best estimates. And for our larger storms, there's even more so. So like your 100-year storm that you plan for, there's a lot of variability in that as well. But we do see a very strong signal that they're going to become much more intense into the future. So with that, I'll leave off with the science. Here's my email if you want to follow up with questions. And I do want to plug the NJDEP Extreme Precipitation tool that's linked here, where you can look at the results from those climate studies from the DEP. And with that, I can now turn it over to Vince to bring us up to date on the actual ruling. So I'm going to stop sharing.
Thank you, James.
Thank you.
If you don't mind, if you can put that link for the New Jersey DEP precipitation tool into the chat so people can look at that as well. Thank you. All right, and next we have Vince Mazai. He has been with the New Jersey DEP for 35 years and is currently serving as New Jersey's first state floodplain administrator. He's a licensed professional engineer with a degree in civil engineering from Stevens Institute, and I will let him talk about the newly passed inland flood protection rule.
All right, well, thank you again for inviting me. And James, that was like the perfect lead in to what we needed to talk about here today. So I have a couple slides that I may have borrowed from you in the past, which I'll just kind of go through quickly. But it's nice how the two presentations fit together. So, a little snapshot of where we are in New Jersey. All of our colonial settlements in the state, like in most places on the East Coast, were along waterways, because waterways were the original navigable areas so that people could have commerce, and they were the roads of the day. So the problem is that most of our state population centers have a stream or a river or creek or something running through the middle of it, which means that there's flood hazard areas. And most of the development that's occurred in the state over the past couple hundred years was not done with flood risk in mind. And so what happens is that people, when they're making choices as to where to live or where to work or where to drive, they're either unaware of the risk, or if they try to find the risk, they go to flood maps. And flood mapping is just like our rainfall data that we talked about, is based on past hydrology and past hydraulic analyses. And so we have data that was collected over like a 50-year period, let's say, and that was used to create our FEMA flood insurance rate maps, which is what generally people will look at when they want to understand flood risk. So if you go to buy a house, your lender's going to look at the flood map, and if you're within the 100-year flood map shown on the 100-year floodplain shown on the map, then you'll be required to get flood insurance, and if you're not, you won't. And that's pretty much the beginning and end of people's experience with flood insurance. The problem is that because of a changing climate and all the variables that James just spoke about, the flood mapping is not an accurate predictor of the actual flood risk. And the methodologies that we've been using are not sound because going forward, because they don't include any climate change considerations. Now, it's essential that if you're deciding where to put your home or where to put your business or where to put a hospital or a school in a community, that you understand the actual risk. And so our task was to say, what can we do to take the flood maps that we have and make them a more accurate predictor of what future flood events will be. And I'm not saying that the mapping is unusable or shouldn't be ever looked at, because it's a good place to start. The problem is that flooding, as we've seen, and I'll show you some examples during Ida, continually goes past the line on the flood map. And because the flood doesn't know it's supposed to stop at that line at the flood map. So it becomes something where people think if they're outside of this line that was drawn maybe decades ago, that they're safe and that they don't need flood insurance and that they don't have a flood risk, but in fact, they actually do. So kind of a snapshot of New Jersey, most densely populated state, over almost 9.3 million people. About 16% of the state lies within a mapped flood hazard area, but more than that lies in an actual flood hazard area. And more than 16% of the population lies within a flood hazard area that's mapped. Just based on the 2019 State Hazard Mitigation Plan, we've got billions of dollars of general stock exposure to the 1% annual chance flood, which is the 100-year flood. Just as kind of a detour, we always talk about the 100-year flood And I've had conversations with people that went along the lines of, well, sir, you need to elevate your house. Well, when is the last time it flooded here? Well, last flooded there in 1955. Well, I won't be alive in 2055, so what difference does it make? And so we had to dispel the myth that like the flood doesn't happen every 100 years on a Tuesday or something, right? It's something that has it's a flood or storm that has a 1% probability of occurring in a 1 year period. We've got over 3 million properties not covered by flood insurance policies, tens of thousands of repetitive loss structures, mostly single family homes, severe repetitive loss structures. We've got over 1,700 critical facilities and infrastructure located within that floodplain. Billions in dollars of post-disaster grants obligations over the last couple of decades. And we have the highest foreclosure rate in the nation. So what ends up happening a lot of times is that properties get flipped, they get bought by people that maybe rent it out, and the renters don't know about the flood risk and they can lose everything. So it's not surprising that FEMA said in 2004 that flooding is New Jersey's #1 natural hazard. Now, we've had a robust state floodplain management program that dates back almost 100 years. And we have some very progressive things that we've done in the state, such as, for example, we regulated a flood that was bigger than FEMA's flood. So we already looked outside that line in some cases. And if you were inside that area, we would require that people build a foot higher than the flood maps show. And we have what's called a 0% flood storage displacement standard, which means if you think about, say, a bathtub full of water and you step into the bathtub, your foot will displace some water and the water has to go someplace. So that happens in floodplains too. If you fill in an area that floods or you put an obstruction to the flow, the water's going to go someplace else and make flooding worse. So we have a standard that says you can't do that in New Jersey. You have to compensate and create flood storage for every shovel of dirt that you put into the flood zone. And we have special standards for critical buildings and multi-residence buildings. We've got very progressive statewide stormwater management policies, stream corridor protection standards. But despite all of the above, flood damage in New Jersey continues to increase. And that is because of climate change. So when you put it all together, most densely populated state, chronic flooding issues that go back hundreds of years, at least 16% of the land lies in a flood hazard area, enormous development pressure. Development itself can increase flooding if it's not managed, and add climate change. That's not a sustainable condition unless we step in and take action. So in 2020, Governor Murphy signed an executive order that was mirrored by then Commissioner McCabe's administrative order, and that directed DEP staff to look at our land use rules, our flood hazard rules, our stormwater rules, our coastal zone management rules, our freshwater wetlands rules, and our highlands rules, and see how we need to amend these rules in order to reflect the reality of climate change. And this kind of overlaps a little bit with what James said, but obviously higher temperature increases the energy in the atmosphere, increases the potential for more intense storms. By the end of the century, we're likely to see 2 to 5 times more storms, and we have had many storms just in this century alone. So as James said, the data that we've been using, the Atlas 14 data, was only last updated with data from 1999. And so when I, as an engineer, if I were designing a stormwater management system and I used those tables, I'm really not even designing it for today's storm. I was designing it for the 1999 storm. And of course, we don't have any idea of we had not until these studies, any idea of what was happening in the future, how this would progress. So this kind of gives you a snapshot, and this speaks to the studies that James spoke of. But in the middle, you can see current precipitation. On the right, you can see future precipitation. So the 100-year storm has increased in some counties by as much as 15% just since 1999. And projecting forward with climate change considerations, assuming the moderate emissions levels and whatnot that James spoke of, the 100-year storm is likely to increase by as much as 50% intensity. So if you have 8 inches of rain today for your 100-year storm, that means you're going to have 12 inches of rain in some counties in New Jersey by the end of the year, by the end of the century, which is not that far away, right? Homes and buildings and businesses and roads that are being built today and bridges are likely to be here in 77 years, right? You know, our kids or grandkids will be able to be still using these structures that we'd be building today. So it's important, essential really, that when people design things and they build bridges and roads and buildings, that it's not just looking at today's flood conditions, but it's also anticipating future flood conditions. Because when you already take an overtaxed stormwater management system like we often have in New Jersey, and then you add more water to it, it increases flood depths, it increases risk to life and property. And again, using Ida as an example, some people have said to us that our regulatory reforms were sort of like a knee-jerk reaction to Ida, and that is not at all true. But Ida is a representation of, unfortunately, what we're likely to see more and more of through the century. And we did look at what happened in Ida to compare it with the flood maps. And what we saw is that the areas that were impacted by flooding during Ida, that the flood was about 3 feet higher than FEMA's 100-year flood elevation. And in some cases that's not unexpected because the precipitation was higher than the 100-year probability. But it was so widespread and it happened so quickly, and it happened in areas that had not previously seen flooding. So I live in Hunterdon County. This picture is on Route 202 in Flemington, and it's taken from the ShopRite parking lot, if anyone knows the area. And when I saw this photo, I did not take this photo, but when I saw this photo and saw 3 feet of water in the parking lot and on Route 202, I was astonished because I know the area and I know that there's no stream or river or anything anywhere near here. So what this all is stormwater runoff from Flemington that either was built before stormwater management was required, or the stormwater management that was placed was, decades old. And so it obviously couldn't handle the intense rainfall. And so Route 202, being the low spot, became the river. And we had fatalities on Route 202 because the flooding came up so quickly that people could not get out of their cars fast enough. And so this is sadly and tragically what, unfortunately, we're going to see more of as decades progress. So looking at some of the responses that the rivers in the state had to Ida, you can see here, there's a USGS gauge along the Raritan River in Bound Brook. And you can see that Ida, on the top left corner, matched the flood elevation of Floyd, which was a much more widespread storm that had, much more precipitation. And what the takeaway from this, though, is that at this location, we've had 3 what's so-called 500-year floods at this location since 1999. So if you're having a flood that has a 0.2% chance of happening every year, so statistically it should happen about once every 500 years, and you're having 3 of them in a 23-year period, that tells you that there's something wrong with the analysis that created those probabilities, and that it's changing. And the next couple slides show you really the core of why we're doing what we're doing. Here is the Millstone River at Manville. And you can see this is before Ida, and this is the same location after Ida. And I think you can see my cursor here. All these homes in this area, you can see that they were all flooded. So there were hundreds of people just right here that were severely flooded. Now, I'm going to overlay the FEMA Flood Map. And you can use this building up here in the top left corner as kind of an indicator. I couldn't line it up exactly right. But you can see here's the FEMA flood map. The blue represents the 100-year flood. The gold represents the 500-year flood. All these people that were in this neighborhood, none of them were mapped in the floodplain. So none of them were required by their lender to get flood insurance. And yet all of them have flood damage that now their insurance companies won't pay for. And so this is a significant, serious issue. If you're flooded and you have flood insurance, it's horrible enough to deal with it. And I've heard so many stories about people still, years after a flood, still not being able to rebuild or not being able to recoup their losses. But if you don't have flood insurance, there's nothing you can do. You're paying out of pocket at that point. And just as a kind of a local example, this is the road I live on before Ida. This is from Google Earth because I didn't have a picture of it before Ida. And this is the exact flood risk might be. All right, so like if you're on Bayshore Drive or Ocean View Terrace, you might have a flood risk. If you're on Hilltop Court, you're probably safe. Okay, so inland flood protection rule. What did we do in response to this? We last December proposed a rule that was then adopted in July, on July 17th, and it made amendments to two sets of rules: our stormwater management rules and our Flood Hazard Area Control Act rules. Key points in stormwater is that if someone's designing a stormwater system or BMP, it has to be designed not for the 1999 precipitation, but for today's precipitation, adjusted with the studies that we talked about, and also for the year 2100 precipitation that's anticipated to occur. And it prevents the use of certain methodologies that are kind of outdated and no longer applicable to stormwater management. So it kind of addressed that issue. In flood hazard, there are three key points. One is that if you're using mapping, and this was kind of a choice we had to make, do we throw out all of our mapping and make everybody recalculate the floodplain? That's not practicable. So we gave people an option. We said, if you want to continue using mapping as your indicator of flood risk, you have to add 2 feet to what we previously regulated before, because we believe that by the end of the century, flooding could be as much as 2 feet higher along our riverine systems. And if you recalculate the floodplain through a consultant, then, which we encourage, then you have to use not the 1999 rainfall, not today's rainfall, but the year 2100 rainfall. And there's also some gaps between our state program and our federal flood insurance program that FEMA identified that we took great effort to resolve, because we want to make sure that New Jersey is fully compliant with the National Flood Insurance Program. So the effect of this, if you see this property right here, and here's a stream, and here's what we'll say the previous flood hazard area was shown on the mapping. So it's now 2 feet higher than that is what we regulate in New Jersey. So that person that lives in the red house might have had flood insurance, but the person in the blue house probably didn't, because they were outside the old line, right? And so yet that person's at risk. And during Ida, as an example, about a third of the flood claim, the flood insurance claims were for people that were located outside the mapped flood zone. And those are people that they're not even required by their lender to have flood insurance. So if you have a third of the policies being paid out for people that are outside the line, when those people didn't even need the flood insurance in the first place, that means there was a significantly disproportionate impact to those areas. So we looked at how stormwater management would change, because we got criticism that having requiring the use of the year 2100 rainfall would oversize stormwater BMPs and take up half the land. So we took kind of the worst case scenario. We took a 2.5 acre forested site up in Sussex County, undeveloped, and we said, well, let's say somebody takes it and paves the entire thing and puts a warehouse on it. And we looked at the amount of land, assuming a lot of variables that we maintained through our different analyses here. And we said, okay, depending on the soil type, if you're looking at the 1999 rainfall, then between 8.6 and 11.2% of the site would need to be taken up by this BMP that we designed. If you adjust it for the 2019 data, which is what the study brought the rainfall up to, it's a marginal increase, only up to 0.4%, depending on what soil type you're on. And then if you project it out into the future, it's between 0.7 and 2.5% more than what the current size of the BMP would be. So this is not going to sink a project. This is not going to make someone not develop something, because it's not that much of an increase. And in the long term, just like anything that we're doing here, there's going to be a financial savings, because piping is not going to have to be replaced. BMPs are not going to have to be redesigned 20, 30, 40, 50 years from now, because it'll be designed to meet today's standard and future standards. Now, if it's a less intense development, say like a residential subdivision, then you can see it's only a marginal increase in the amount of space that's needed for stormwater management BMPs. So there's two tables in the stormwater rules. One is the current precipitation adjustment factor. So this takes the NOAA Atlas 14 data and shows you how to adjust it for the 2, 10, and 100-year storm, depending on what county you're in, to bring it to the 2019, which is the extent of the data in that study. So that brings you to today, more or less, right? And then there's another table in the rule that says, well, this is what's going to happen throughout the end of the century. So if you're in, say, Warren County and you're designing for the 100-year storm, you would take the NOAA Atlas 14 precipitation and multiply changed because I'm sorry, the recording was starting and stopping there. I don't know if you heard that. FEMA method 2, which is the title method, is unchanged because this rulemaking that we undertook focused on precipitation driven flooding and not sea level driven flooding. There's going to be another rulemaking by the end of the year that will incorporate what we know about sea level rise along the coast, and will open up all of these rules and then some to make changes there. But this rule that we're talking about now just relates to precipitation driven flooding in riverine systems. Now, if you're going to use a FEMA flood map, then the design flood is actually 3 foot higher than FEMA's map, because before we were using FEMA +1. We were saying, look at the state study and look at FEMA +1 and see which one is higher and use that. Now we're saying use the state study +2 or FEMA +3, which is ever higher. So sometimes you can design to that, and sometimes it's difficult for you to design to that. So there's different methods to calculate floodplains. If you're using one, there's 2 different methods to calculate it. In both cases, you have to increase the amount of water in the river by 25%. And then in this case here, it would have to be 2 feet above that calculation. There's a way to approximate floodplains. If there's no mapping, it's very conservative. So we only added 1 foot to that. And this is where I think a lot of people are going to land if they think that the flooding is overestimated by adding 3 feet to the flood map, then they can calculate it themselves, but they have to use the table that's in the flood hazard rules. That's the same table as in the stormwater rules, but it just focuses on the 100-year storm. And then last slide, I mentioned we opened up the rule in a couple places to address minimum federal requirements under the NFIP to make sure that nothing that we allow in New Jersey falls below federal minimums. And that preserves our ability to get help after a flood, economic return on things and whatnot, and federally backed flood insurance. So it's very important that we made these changes. And I'm happy to answer any questions that you have. And I also should point out that I have Gabe Mann is on the call with us. He's the author of the stormwater management rules and penned the changes that were done there. And I largely did the flood hazard rules, but both of us are here to answer any questions you might have.
Thank you, Vince. I apologize if the internet connection is a little funky. It keeps kicking me out of the call, but I think that's why you heard the stop and start recording. I apologize for that. All right, so we would like to open up the floor. We have Dr. James Shope, we have Gabe Mahan, and we also have Vince, who just spoke. So if anybody has any questions for our speakers today, you can come off mute or we can address them in the chat. unless we left everybody speechless.
We can keep talking. I'm sure James and I have plenty more that we could say.
Yeah. It's interesting to see, since we have a lot of coastal communities within the New Jersey CRC, you know, it's interesting to see the climate precipitation change in northern New Jersey versus like coastal New Jersey. And coastal communities are not only battling variable precipitation, but also the tidal and sea level rise and all that type of flooding as well. And I know, Vince, there's something coming out for coastal communities in the near future.
Yeah, the two big takeaways from that is based on projections of sea level rise and the likely range that came from the Rutgers staff report, there's a likelihood that sea level rise along the coast, assuming moderate emissions levels, would be between 2.1 and 5.1 feet by the end of the century. And so what we're taking is the high end of the likely range, which is, we'll say, 5 feet. And so and the corollary to that, though, is that there's land that's above sea level today that will at some point be underwater, either twice a day during high tide or permanently. And so that land area is at particular risk of inundation. So we're identifying that land as the inundation risk zone. And it's basically land that lies within 5 feet of sea level today vertically, because it has a likelihood of being underwater. So there are a lot of
coastal flooding and extreme rainfall and the like. So, you know, taking these kind of rounded off measures and, you know, taking our FEMA flood maps, raising them by that is a good way of taking a very proactive approach to it, even though it's so hard to pin these down. So, yeah. It does look like we have a hand raised, though.
Yes, we have Charles. You can come off mute.
One of the things you talked about, Vince, was the roadway to your house. So I realize these flood maps and all this construction regulations are pertaining to private property on how to do construction and raise your houses and stuff, which a lot of people do. But there's no sense having a piece of property in a flood zone area where the roads and all the egress to the property are below flood and are inundated on a recurring basis. You know, my house is inaccessible, I don't know, 15 times out of the year for a day to 3 days. So what is the state doing about towns and about raising roads? I mean, it's one thing to raise your property, but with the slopes and everything and building walls around your own property, waiting for the town to build the roads, is there a program that's guiding towns on how to get the neighbors to, like the homeowners, to raise their property and then follow suit with raising the roadways? So at the end of the day, you have a property that's actually usable by people. You understand?
It's so different, the dynamics between flooding in tidal areas and non-tidal areas. It's very hard to model. So for example, in my area where I live, it's fluvial flooding, riverine flooding. The road could have been raised so that it would be less likely to be impacted by a flood. If you're on a barrier island, then, you know, unless you raise all the roads by 5 feet, no problem. So this, we feel, is like a good first step to say, well, this is what the actual flood risk is, everyone. And everyone should be mindful of this when they develop, including the state, including the county and the municipalities. And everything that can be done should be done, is really what we're trying to do here.
So if I could follow up just a second, so what's happening is people are raising their homes. They're spending $20,000 to $40,000 on a 2-block wall and backfilling their lot. so they can drive their car up a little higher so it doesn't get flooded, and raising their individual property and putting a lot of money in. But the towns are not doing side streets, or the state is not doing highways. The county isn't doing a lot of the major access roads to the barrier islands and stuff like that. So what's the sense of doing anything if you can't get to it? It seems, I realize you're saying it's like the cart before the horse here. Isn't it? Don't you need access as a primary thing, not a tertiary or a nice to have?
I think it would be.
Shouldn't the state do something about it?
Well, we are by setting the standard and by requiring that when someone does improve a road. So if a municipality is going in and putting in new stormwater systems or reconstructing a road or adding a lane or adding a shoulder, they have to elevate it unless they can show us that they can't.
What law drives that?
The Flood Hazard Area Control Act.
Oh, so it is written in there. I wasn't aware of that part.
Yeah, it's required, but the problem is that, you know, if I put my engineering hat on, like sometimes it's going to just not be possible, right? I mean, with enough money and enough time, you could theoretically raise every road. And so over time, we're hoping that will happen. But the first step is to say, this is what the standard is. This is what you should be doing. And we're going to require you to do it, municipality, state, county, unless you can show us that it's impracticable from a variety of reasons. And it could be, sometimes it might make flooding worse for people, or it could, you know, you could have a situation where it's making things better for one community and making things way worse for another community. It's a very complex thing. So I completely agree with you that it's essential that our transportation system is elevated and as safe as possible. But, you know, sometimes it's not possible to do, unfortunately. You know, like Route 35 is a good example. When it was destroyed after Sandy and it was rebuilt, there was some talk about, well, maybe we should build it higher. And there were, I forget how many, I think it was like 1,000 and something driveways that attached to that portion of the roadway. And so all those properties would have to be elevated. I think it was like over $1 billion they felt that it would take to do something like that. So at that time, the thinking was, well, let's just put the road back and so that it's serviceable during non-flood conditions, and then we'll take a look at it later on. And so now is later, and that's what we're trying to help people do.
It seems that that's continuing as it is. Thanks a lot. Appreciate it.
Sure.
Thank you, everybody. We have reached the end of our time here. You will see a poll at the end of this Zoom. If you could just fill that out, that's a post-meeting evaluation for today's technical assistance coffee chat. I would like to thank our speakers today for joining us, and hopefully this coffee chat will allow you to reach out to them in the future with any questions about the Inland Flood Protection Rule and changing precipitation rates in New Jersey. And thank you, everybody. I hope you have a good rest of your day and stay dry.